Hi, I'm Dr. Lillard. I think most of us have seen some version of the periodic table, which is a chart that organizes and categorizes the different elements. But what does it mean for something to be an element? To define an element, there are three terms we'll need to use in some combination: proton, atom, and element. Let's use carbon as an example. An atom is the smallest structural type of matter having the set properties of the element. And an element is composed of atoms which all have the same number of protons. The protons are shown in red for this particular atom of carbon. Put another way, each atom of an element is defined as having a unique number of protons called the atomic number, Z. The atomic number can be found at the top of an element's block. For carbon, the atomic number is 6, which means that carbon has 6 protons, always. And it's the fact that all carbon atoms have 6 protons that defines the element as carbon. Just so you know, the blue particles are neutrons. Different atoms of an element can have different numbers of neutrons and still be the same element. We'll learn more when we study isotopes. Remember, the number of protons defines the element, so if you change the number of protons, you change the element. If we look at the periodic table, we notice that each atomic number is only used once, starting at 1 for hydrogen and ending at 118 for oganesson. For example, only carbon atoms have 6 protons. No atoms of any other element have 6 protons. And only helium atoms have 2 protons. No other element has 2 protons, and so on. Each element also has a unique chemical symbol corresponding to its name. The symbol is an abbreviation shown on the periodic table having 1 or 2 letters. If the symbol has 1 letter, capitalize it, like we see here for carbon. If the symbol has 2 letters, then capitalize only the first letter, like with helium. Also, don't assume that the symbols are always the first 2 letters of the name, because most of the time they are not. Here's the other thing. You will be expected to translate between names and symbols for a list of elements, depending on your specific class. I really don't want to say this because I'm not a fan of memorization, and there are far better ways to learn most things in a chemistry class, but learning the elements is basically memorization. My advice is to go old school and make physical flashcards on pieces of paper. On one side, write the name. Spelling counts. On the other side, write the symbol. Here are my flashcards for carbon and helium. Now, when you study your flashcards, I suggest a couple of things to encourage you to actively think about the learning. First, write down the answers rather than just think them in your head. This will require you to spell the symbols and the names and will help shift the information to long-term memory so you'll remember it better. Second, mix up the cards so that when you go through them, sometimes you'll see a name, like we saw with helium, and sometimes you'll see a symbol, like we have with carbon. It might seem more difficult at first to be switching back and forth, but this activity in your brain will help you recognize the names and symbols under different circumstances. And that's the introduction to the elements. We define an element by considering its protons and atomic number. We identify an element from its chemical symbol, and we'll study the elements by being able to translate between names and chemical symbols. If you're looking for more information about the periodic table or atoms and isotopes, we cover those topics in other videos linked here. See you next time.